Yeah. Perfect, thank you. So good morning to all, and welcome to this second webinar organized by the European project GIFT and MAESHA. So today we will talk about system architecture and interoperability to achieve grid flexibility on islands. So we will focus on grid-centric use cases, and we will cover several topics. So we will discuss the functions and the related components that are required for the identification of a need for flexibility up to the activation of on-site flexible assets. So of course, we will talk about flexibility management platforms, and we will give a quick overview of the flexibility sources that will be piloted in the two projects. We will also talk about interoperability, as it is a key enabler for the smart grids. And we will also have a presentation of Olivier Geneste about the activities of the data management working group of the bridge initiatives. So today we will have an enlightening presentation from partners from the two consortiums. So on MAESHA side, we will have two partners from the Technische Universität of Berlin, which is a public research university located in Berlin. We have Boris Heinz, so professor at TUB, who is a project coordinator of MAESHA. We will also have Nicolas Schön, a research associate with a focus on integration of renewable energy in microgrids, energy system modeling, and access to energy in the global south. So good morning to both of you. On MAESHA side, we will also have Christophe Gucci, senior project manager at Cybergrid. So Cybergrid is offering innovative ICT-based flexibility management technology, consulting services and research in the EU power sector. And in MAESHA, Christophe is our technical coordinator, also in charge of the activities linked to the flexibility management and trading platform. Good morning, Christophe.
Good morning.
And finally, on MAESHA, we will have partners from Centrica, which is a flexibility aggregator with a portfolio of 3.8 gigawatt of flexible assets across UK, Europe, and North America. So we will have Alexei Mashlakov, innovation specialist in charge of the design of the flexibility market framework and of the flexibility products requirement for the island of Mayotte. And Vladimir Vrabel, optimization engineer, coordinating the activities of Centrica for the energy management system to enhance grid flexibility, also involved in the development of the virtual power plants. So good morning to both of you.
Good morning.
So if we continue of the GIFT side, we will have Igor Steiner, head of the energy and ecology solution at INEA, which is a Slovenian SME involved in informatics, energy, and automation. So the company commercializes solutions such as energy management system and demand-side management system. And in GIFT, Igor is a project coordinator.
Morning.
Good morning. We will also have Luc Richaud, project manager at ODT, which is a software company specialized in physics-informed machine learning applied to maintenance, operation, and management of low-voltage networks. So the company develops and commercializes a suite of supervision and decision support software, leveraging smart meters data. So in GIFT, they are in charge of the development of the grid observability system, which provides a state estimation of the low voltage network and also triggering flexibility when it's required. Good morning, Luc.
Good morning.
And we will also have Dune Sebillo, so smart grid engineer at Trialog, and so who was in charge of the use cases definition, system architecture, and also in charge of the interoperability aspects for the GIFT projects. Good morning, Dune. And finally, we will have one extra guest, so Olivier Geneste, director at Trialog, but also chair of the data management working group of the bridge initiatives, who will present the activities. Good morning, Olivier.
Good morning.
So thank you all for your participation today. I propose we quickly start our webinar with a brief reminder of what are the two projects. And I think we'll start with GIFT, and Igor, the floor is yours.
Yeah, Thank you, Marilyn. The GIFT project actually is already in the last phase of the execution. So we just working now on the deployment of these flexibility systems on 2 islands. Actually, our implementation concluded 2 demonstration sites. One is Procida Island in Italy, and another is Hinoya Island cluster in Norway. Very different islands. Procida is a small island in Mediterranean Sea. The Hinoya Island cluster actually is a set of many islands. You see this on the picture, and it's very north. Actually, is behind the Nordic Arctic Circle. The aim of the project is to increase the penetration, to have better visibility of the grid, of the flexibility, makes the synergy between different sectors, reduce the using of hydrocarbon fuel, and to make replicability on following islands. GIFT is a well-balanced consortium, consists of 17 partners from 7 countries.
Thank you, Igor. I think we can continue with the introduction of MAESHA, Boris.
Yeah, good morning also from my side. MAESHA is a name from the local language on Mayotte and means future. Mayotte is in the Indian Ocean and small island next to Madagascar with 500,000 inhabitants. And the aim of MAESHA is to decarbonize the energy system of the island, which currently is powered by 95% diesel generator electricity. And to do so, MAESHA has several special objectives: the large-scale demonstration of renewable energy systems, which goes hand in hand with required flexibility services when including volatile renewable energy systems. Therefore, the smart platform aggregating flexibility services development is at the center of the project to work on the flexibility solutions. For that, local communities are involved in order to tailor the solution to partners on the ground, industry, society, to have a holistic picture. Tailored energy markets and regulatory frameworks play a role in the sense that MAESHA looks also at the framework conditions that would in the future enable such activities to be implemented through industry partners, and the demonstration of the solution and the study of replicability on follower islands is included as well. MAESHA is still a young project. It turned 1.5 years just recently. It has 12 work packages over 48 months, and we are 21 partners from 9 countries.
Thank you, Boris. I forgot to mention, but for all the participants, if you have any questions, please feel free to write them down in the question session, and we will have a Q&A session at the end of this webinar to answer them. So we wanted to start maybe with a brief reminder of what is flexibility, how it works, and we will continue with Alexei giving some recommendation or some consideration regarding the market design of the flexibility markets. Alexei, the floor is yours.
Thank you, Marjolaine. Generally, flexibility is a very broad term to discuss it in brief, but I will focus on 3 dimensions of the flexibility, and I will look at them using the flexibility map. So the first dimension that I wanted to mention is the technical flexibility. This is the most common definition that you will probably hear about the flexibility, and this is defined as the capability of the system resource to deviate from the baseline operation mode to alternative operation mode by modulating feed-in or feed-out active or reactive power in scale or time. And typically it's done in response to a certain external signal. That could be a price, or it could be some grid parameter. The sources of flexibility are typically categorized to demand side, supply side, grid side, as well as sector coupling and energy storage. And the parameters of the technical flexibility are usually stated in terms of ramping rate, the power, and the duration of the response. Now, the second dimension of the flexibility is operational flexibility. And it's, in this case, it's defined as the ability of the system to contain a certain disturbance at any node of the system in order to keep the system secure. The categorization of the operational flexibility could be divided into such categories as the flexibility for energy. In this case, this type of flexibility is needed in order to maintain the energy balance between supply and demand on medium to long term. There is also flexibility for power. It's also balancing the power and power production and power demand, but already on a time scale of from minutes to sub-seconds. Both of these flexibility needs, they provide the system-wide value for the power system operation. There are also location-wise needs for flexibility, and for example, flexibility for transfer capacity ensures that there will be a lack of congestion in the network, while flexibility for voltage ensures that the voltage will be at nominal within the nominal operating range. Finally, there is the third type of the flexibility dimension, which is the market flexibility. And in this case, it's already defined as a commodity or a service for another entity. It could be categorized in terms of service level, requirements, grid location, and state dimension. Market flexibility brings us also to the definition of the definition and objective of the market itself. The objective of the flexibility market, if you go to the next slide, please, Matt.
Yes.
The objective of the flexibility market is actually to connect the flexible sources on one side and procurers of the flexibility services on the other side. For the flexibility sources, it provides the opportunity to valorize the value of their flexibility, while for the system operators, for example, that procure the service, the market is opportunity to procure the services at lower cost than currently integrated methods that the system operators, for example, are using. But the benefits of the market are only realized in terms of in the condition of competition between possible service providers, and this is not the case in all of the cases. And in that sense, there are other possibilities to provide the coordination between the source flexibility and the procurers. Such opportunities could be categorized as network connection requirements, dynamic tariffs, or regulated cost-based remuneration for service provision, and so on. Now, if we go forward and look at the case of the Mayotte Islands, as in many other geographical islands, we are looking at the system operated by the vertically integrated utility. In some cases, there is little competition on the generation side, but the transmission, distribution, and supply are carried exclusively by the vertically integrated utility. And in the scope of MAESHA project, we are aiming to integrate the flexibility market into the operation at the transmission level. We are looking into two types of products. First one's the balancing products, and we consider such products as fast frequency reserve, frequency containment reserve, and automatic frequency reserve restoration, and the parameters of these, we are developing the parameters of the services so that they are tailored to the context of island power system, such as low inertia, for example, condition. And we are also looking into bilateral voltage control use case, where, for example, the voltage control service could be provided directly without the market to the system operator. And in the design,
Alexei, can I ask you to go to conclusion, please?
Yeah, I'm about to conclude. So in the overall design, we are hoping that the integration of the flexibility market will contribute to more cost-efficient system operation and reduce emissions that are driven by the diesel generation, which is the main source of supply and balancing on the island.
Thank you.
Thank you.
So yeah, it was a really interesting presentation of what is flexibility with a good reminder of a flexibility market. Also, what could be interesting is to discuss the different assets that could provide flexibility. And here we will quickly talk about the flexibility sources that will be piloted in the two projects. So I will give the floor to, I think, Boris from TUB.
Or if I may.
Yeah, Nicolas, sorry.
Great, thank you very much. Good morning also from my side. I will jump in here and put you on the large screen for me if that's okay to show you what we have in mind towards the flexibility assets that will be included in the MAESHA project. Unfortunately, I cannot bring any pictures for now because the deployment of the assets will be starting at the end of the year. But we already have a very sophisticated idea of and this map, which flexibility assets will be included in the project. And well, this illustration here, we could add maybe or imagine a line separating this illustration into half. So we have the left-hand side that basically describes such flexibility assets here that are actually already in place on the island, but that require aggregation via energy management systems, so to say. So starting with number one here, we think of virtual power plants. That means the centralized management of numerous plants, both renewable and fossil ones, to be controlled. That also includes the self-consumption that might be decentralized solutions spread over the island and already in place that we could aggregate here. The second pillar that is included in these already existing flexibility sources we just need to activate, let's say, is the industrial energy demand or the industrial energy management, which means that we have detected some industrial customers here, like the harbor, for example, the port of Mayotte, where we see certain devices that could be switched on or off or shifted in their demand, probably with the use of local generators to shift these activities. And then there is, of course, the actual the community itself. Speaking of residential demand response here, that will be incorporated in the project, and which we think can contribute a lot as the willingness to participate in such programs evidently is very high on islands. So we will explore this. Potentially here, air conditioning could be a valuable source of flexibility. And on the right-hand side of this figure, we see such solutions that actually come new with the project, that will be introduced as new to the energy system of Mayotte, and that also trigger synergies to other vectors. First of all, that's the mobility sector. We will include electric vehicle charging in the project. That is, first of all, to provide a bidirectional possibility of charge, meaning that we can charge or discharge the electric vehicles connected to the grid on such stations that will be, as you can see in step 6, hybridized, which means that they are already are equipped with a PV production on the station itself. Then the last thing that is or will be included is storage. Yeah, when we will increase the share of renewables here on this today, mainly diesel-based power supply, we will lose inertia in the system a lot, and this we should compensate. And there are technologies now available to provide virtual inertias. That is mainly via inclusion of power electronics, such as inverter systems that act as inertia to the grid, let's say. And these are connected with the storages, especially the battery storage used for short-term flexibility provision here, and also the long-term energy storage will be included. That is a hydrogen storage, so the electrolyzer being connected to the grid will offer long-term flexibility to the grid, so to say. I think that's the overview.
Thank you, Nicolas. As mentioned, so GIFT is a bit advanced, more advanced at MAESHA. So Igor will quickly explain what kind of prosumers can be recruited for demand response. Igor, the floor is yours.
Yeah, hello. Thank you, Marilyn. Yes, on the first roundtable, I already presented 2 energy storage systems working with hydrogen. Actually, there are somehow hybrid systems. So today I will present some of the demand side flexibility sources. These 3 pictures that are shown here are all from Norway. Hinnøya Island cluster presents schools. So on the project, we have 2 schools with quite big boiler for heating of the building. It has very good potential, as shown on the screen here. Then we have kindergarten. This is a little bit smaller with a flex potential. And the third is Halogaland Craft headquarter, which flexibility sources is using for heating, ventilation, and air conditioning. So all these 3 flexibility sources here is using for heating. The 4th one here presented is the wholesaler who has 2 large freezers using for storing foods. Actually, it's a distribution wholesaler. And here we are using these flexibility sources with these freezers. Not shown on the screen, in Italy, we have the sewage lifting plants, which is also quite good flexible sources because it has some accumulation of the water behind. These pumps are not running all the time. So we have this flexibility to start and stop these pumps on depend of the status of the grid at that time. So these are the main flexibility sources. As said, these are on demand side flexibility, but behind we have also 2 energy storage systems where we are storing the energy as a hydrogen and also in the lithium batteries. Thank you.
Yeah, thank you, Igor. So now that we have a quick overview of which sources could be interesting for flexibility, we also need to improve we need to have other functions to detect a need for flexibility. So we will try to overview the whole value chain, and we will start with a presentation from ODT on the topic of enhanced observability. Luc,
hello, good morning. Thank you, Marilyn. Well, yes, so in order to set a flexibility market, you need to, well, identify And in the case of GIFT, we couldn't use the same issues as identified in MAESHA, which are the peak shading and the balancing. The two islands we are working on are actually connected to the national grid. The thing is, when you activate flexibility, often for purpose like balancing production or consumption, you as well have an impact on the local grid. And if you do it blindly, you might solve issues on the low voltage side, or you might create some. So the focus in GIFT has been to provide the necessary insights to the DSO in order to access the flexibility market and benefit from it, not only being a third stakeholder in this scheme, but being a major stakeholder that validates flexibilities and that use it in order for its own operation. But to do that on the low voltage side, we need to understand more the operational conditions because there is no real-time data coming from the low voltage network. We often don't know if a customer is being badly supplied or not. But now we have some more data thanks to smart meters deployment. So if you can go to the next slides, please. Yeah, so the point in GIFT is to digitize the low voltage network in order to have real-time insights on it and trigger the flexibilities that are required to solve the issue we might face. So the principle of it is that we gather historical smart meters data. So we are currently collecting smart meters data across all the islands in Norway, and we gather historical real-time data. And thanks to those two, we compute topology and we compute training of an observability model. And this gives us the grid observability model that is used then in real time with real-time sources with either SCADA data, IoT sensors. This is what has been used in GIFT because it was easier to implement, let's say, and potentially meteorological data in order to use the grid observability model and get a real-time state estimation of the low voltage network. So this real-time state estimation provides two information: an evaluation of the quality of the voltage plan and an evaluation of the load of critical assets. In our Norway demonstration sites, we are monitoring 36 three-phase voltage points in order to ensure that they are all in the nominal values, 230 plus or minus 10%. And we are monitoring 120 substations to make sure that they keep under their nominal load. And thanks to that real-time state estimation, this is a 10-minute time step value that is provided every 10 minutes. We monitor voltage excursions and the overloads of on grid assets that are identified as critical. And here they are the secondary substation. And if ever we encounter an issue like a voltage excursion or an overload, we send to the VPS that is developed by INEA, and that is the place where the market matching is made, an adaptation request to ask them to activate some flexibility in order to mitigate the identified issues. So basically, the system ensures that each flexibility activation will not create the issue we are monitoring, so the voltage excursion and the overloads. And if ever an issue is forecast, the DSO can purchase flexibility to avoid them. They can be a stakeholder in this market.
Sorry to interrupt, Luc. Can I ask you to go to your last slide?
Yeah, sure.
Thank you.
So concretely, this is two systems that are interfaced. We have on the left part, you can see the grid observability system that is monitoring all the points in the map or the top left corner, and we have the value and the forecast coming from RDN of the loads and the voltages, and every 10 minutes the grid observability system is sending to the VPS an adaptation request that says there is an issue, so please activate flexibility, or there is no issue, so you can activate flexibility up to this amount without creating one. So those two systems are currently running and up for deployment in the last phase of the GIFT project. Thank you.
Thank you, Luc. So if we continue with the different functions that are required for a flexibility market, we need also to have an enhanced modeling, like a lot of different modeling tools. And here we will have a presentation from Nicolas from TUB on MAESHA side. Nicolas, the floor is yours. Yeah,
it's great. Thank you very much. Yeah, so the enhanced modeling we apply to give answer on the flexibility requirements on the islands. I think we can distinguish in different timescales. So for the MAESHA project, we have first of all a very long-term timescale with the energy economy modeling we apply there, which also gives answer to us to understand what the future energy system will look like, first of all. So that's important to know what flexibility assets will probably be in place depending on different policies, infrastructure of the energy system, and so on in the future. Whether assets will be there, meaning what level of inertia can we expect, and so on. So this is something we apply, we answer with the energy economy modeling framework that combines an economic perspective of the island of Mayotte with the industry sectors that are included in the demand, especially of the energy system towards the energy system model. So this combination. This is the first pillar, so to say, and the second is that we require modeling to give answer to the flexibility requirements on a very short-term basis. There are two things explored in the MAESHA project. First of all is the advanced forecasting models for energy supply and demand, in which we try to model the exchange, the energy exchange inside the island, especially supply and demand here. So they're based on historical data of PV production and demand that was recorded on the island of Mayotte. This was used to train different forecasting algorithms that actually build on artificial neural networks here and some decision trees. And the best algorithm in this was chosen to be implemented into day-ahead forecasting. That means that the local DSO uploads very recent data, or the most recent data they have recorded on PV feed and then also demand before I think 11 in the morning, and data ingester would fetch for the last 7 days here actually to report and run the algorithm and then report the estimated PV feed in and also demand for the next day. So we can estimate the flexibility that's required for the next day. Then there's the third pillar here, frequency simulations. So as we've just heard, the market Mayotte also reacts especially to the frequency deviations and to ensure a stable frequency. And therefore the products on this market, they must react on normal deviations, let's say, over the day, but also on extreme events, maybe fault events even. And therefore models that use harmonic or even transient mathematical description of the energy system and the behavior of the frequency independency of certain events have been developed. As illustrated in this third figure, we can then study the impact of such events on the frequency deviation, and with this we can conclude on product sizes, on the length of products that are required to not jeopardize the grid stability in terms of frequency here.
Thank you, Nicolas. I will maybe just make here a quick intervention. So I see that the time flies, so I will ask the other partners who will make intervention to try to stick to the schedule. And of course, if we don't have enough time for the question, you can still write down all your questions and we will answer them and send it back to you, the answers. Christophe, you're the next one to present the flexibility management and trading platform that will be implemented and demonstrated in MAESHA. The floor is yours.
The flexibility management trading platform is one of the key developments in the MAESHA project. Let's explain this a little bit from the left side to the right side of the picture. So historically grown, there is a vertically integrated utility. In this case, let's say it has the role as a system operator, and there is a SCADA system which has been operating an HEC, automatic generation control, which manages the generation of a number of generators, mainly diesel generators, which supply all the demand on the island and additionally provide the flexibility for frequency balancing. So in the future, this SCADA system is being updated at the moment. In the future, there will also be a distributed energy remote management system. So, and which means external flexibilities could be added to the generators and could support the generators in providing flexibility. And as we heard before, the aim is to reduce the carbon emissions from these generators. So for this purpose, we introduced the FMTP. And since we are in utility, we have a critical infrastructure, and which means we need to open this critical infrastructure to the outside world, and the FMTP will serve as a gateway to the outside world. It will be responsible for trading of flexibility, activation of flexibility, monitoring it, and also the settlement. And the counterparts of communication will probably be virtual power plants to manage large scale and small scale flexibilities, but in case of large batteries or other generators or large consumers, they could also have a direct communication with the FMTP. So next slide, please. Yeah. So what are the use cases for the flexibility management and trading platform? As mentioned before, we are focusing on frequency balancing by these distributed assets to support the centralized assets. And here we're looking at the FCR, primary and secondary control area. And additionally, we have a use case for reduction of peak load by distributed assets. And we differentiate between peak load system level, which means we reduce the cost of peak generation, and reduction of peak load on a local level, substation or feeder level, which means that we want to mitigate potential grid problems with the same service. So for the application of the FMTP as a software, so it should support trading of flexibility and management of the grids and the contracts, flexibility contracts. It should support the real-time monitoring, dispatch of the distributed assets, where we differentiate between real-time dispatch for secondary control and scheduled dispatch for the peak load reduction. And this, of course, there must be evaluation of the service provision, and finally, if the services were provided correctly, there could be settlement and payments to the distributed resources. Thank you.
Thank you, Christophe. So on MAESHA side, we have the FMTP as described, and on GIFT side, we will have a similar platform, which is the virtual power system that will be presented now by Igor.
Yes, virtual power system, or shortly VPS, is a central control system who manage the flexibility on the grid. VPS is automatic trading, automatically trades flexibility between participants. So on this picture, we see we have electrical vehicles that I forgot to mention before when we described about the flexibility sources, smart houses, factories, renewables, some commercial buildings. So all these flexibility sources are connecting to the central virtual power system, and this virtual power system then managing the flexibility on the grid. This VPS could be used in a different configuration, so it can be used for frequency servicing, as Christoph already mentioned, FCR and FRR, or could be used for congestion management that we are using, for example, on the GIFT platform. Just to mention, it's market-oriented and enable non-invasive operation instead of curtailment. So it's bottom-up principle of work. So it's really working on the volunteer approach that prosumers can offer the flexibility to the system. Next slide, please. Yeah, here is the configuration of this VPS platform. So as I said, VPS, the virtual power system, is the central control system inside of this smart grid configuration. On the top of the virtual power system, we have we set the grid IT system, which consists from grid observability that Luke already presented a few slides earlier. We have predictions services for energy, for supply and demand status, for the prices, for prediction of the weathers. And all these components are connecting together with enterprise service bus, which takes care about the communication between the device. On the lower side, we have prosumers. We said already about factory EMS, about energy management system, about hydrogen storage systems. We have e-ferries, harbors, EMS, and all of them are connecting with flex offers that will be also presented in the next slides. On the right, we have just a short list of the prosumers that are using on these two demo sites. So Hinoa is maybe more oriented in the transport sector with ship, e-ferries, harbor, EMS. Norway has already a lot of EV cars on the market, so EV charging is very active there. We have this factory EMS for wholesaler already presented, and storage, energy storage system. On Procida, we have also a little bit of charging, EV charging. This is still in the process now. We have some factory EMS, which is actually the public infrastructure with these pumping stations, and we have smart energy hub for energy storage. Okay, this is just in a few words about the configuration in GIFT. Thank you.
Thank you. Thank you, Igor. And now we will, so now we do have a better view on what is this flexibility management platform. We also need EMS, which directly controls the assets. And here we will have a presentation from Centrica, and Vladimir, the floor is yours.
Yeah, thank you. So this is a conceptual diagram showing a virtual power plant to be deployed for MAESHA on a rather low level. So we have PV assets and residential demand assets, which can provide some flexibility and which are aggregated into one pool. We receive the measurements from those assets and send it further down the line. The asset measurements are used for pool level forecast, and based on this forecast, we make bids, flexibility bids to FMTP platform presented by Christoph. And if our bid is accepted, then we receive a pool dispatch, which is then disaggregated so that we have activation for each particular asset, and then we send this activation to those assets, and the loop is closed. So this is flexibility activation in short. Let's talk about the challenges. So the first one, rather not technical, is a participant recruitment with the proper assets which can participate in a VPP and provide some flexibility given a specific situation at Mayotte. Then second, we expect that some effort will be put spent to make sure that we can communicate with different assets with the right protocols. Then next, in order to participate in flexibility market, we need to have a reliable asset and pool level forecast. We will use mainly PVs and air conditioning, so we need accurate weather predictions. And also what we see as a challenge is to make sure that we understand air conditioning usage patterns so that the user comfort is not affected. And lastly, our intention is to, well, the VPP infrastructure will be hosted in Europe, but the assets are in Mayotte. So we need to investigate on execution delay, which can be also caused by, we also have to make sure that the internet connection we use for communication with the assets is reliable and fast. That's it.
Okay, thank you, Vladimir. So here we have a really nice overview of the different functions and components that are required. And I propose we now move to our next topic, which is interoperability. And we will first have a presentation of the main challenges linked to the topic by Christoph.
Yep. So interoperability for us means we need to make different systems communicate together, with each other. So let's start with the challenges on the general situation. So we look at some protocols that might enable interoperability, support interoperability. We find out that there's a lack in Europe-wide harmonization, which starts at the market. So the market organization had to sell in all European countries, which means it's all be nearly impossible to find one protocol or one family of protocols that would support all the whole European markets. Then low harmonization market organization also means that there is not much common understanding of what is a flexibility product and how it's defined. And for instance, baseline calculation is more of a secret knowledge than a standard, and it's very variating from country to country and from TSO to TSO. And furthermore, which is also increasing the complexities, there's an increasing awareness of security issues. So again, this is critical infrastructure. We need to be aware that somebody might try to hack into the system, and we need to prevent any intrusion. So the challenges on the system level now mean that we investigated which protocols would be feasible to support the following functions that we would need on the FMPP side for them to enable a market, which starts with registration of the assets and pre-qualification of the assets, the daily market operation, and also during the day we need to monitor the performance of the units, and we need to send out activation requests. And at the end of the day, or at the end of the month, we need to validate and evaluate the performance of the assets, and we need to have a settlement process. So unfortunately, we did not find any protocol that would support the whole range of these functionalities. Most close was the N3 common information model, which is now pushed by the European TSOs, which turned out to be very helpful and the best suitable for our purposes. So based on the European style market profile, so we found out this is a major solution for TSOs. It's not yet mature for distribution systems, but we see a very positive development in some countries like France or also Slovenia. So we are comfortable that this will be also a major solution in 5 years for distribution systems. So a challenge, of course, is the complexity of the data model. There's an exhaustive data library, thankfully it's freely available. So users don't have to pay for the standard, but still it needs time to understand this data model, understand the standards, and it needs time to implement. On the fleet level, we have a different situation. So there is no common standard that could be applied for all different applications. And in many cases, the developers fall back to very well-known and widely accepted protocols like Modbus or IRC-104, but these are decades old. And for this reason, already partly outdated, for instance, when it comes to security concerns. So, and at the moment, we're looking for more modern standards, but there are standards on the market, but all of them lack a wide acceptability or are too complex. So at the moment, we did not find any standard which would be able to be applied for all the different applications in MAESHA on the fleet side. So these are the challenges that we face at the moment.
Thank you, Christoph. So yes, as you can see, to tackle these challenges in MAESHA, we decided to rely on standards, as it is also done in GIFT. And here we will have a brief presentation of Dun about what is done in the project.
Yes, thank you, Marjolaine. So in GIFT, we mostly used the flexibility offer protocol, flex offer protocol, which is a flexibility trading protocol. And it enabled a lot of interoperability within the project because it provides a common representation for all flexibilities. So no matter what the flexibility asset is, the representation and the comprehension by the VPS or the aggregator is the same. So yeah, we used a lot this protocol, which also enables the aggregation of the flex offer even on several levels. So I just wanted to use this occasion to mention that we have launched a user group for flex offer within the Flex community. And the aim of this user group is to harmonize the specification and continuously improve it based on the experience of the users. So if you're interested, you can check the link below. And if you can move to the next slide. Yes, thank you. And so the other thing that we did in GIFT for interoperability was to have a lot of testing. So this was done on the 3 different levels. The first one is the component level, on which we have a test in order to check the behavior of each individual component of the system. So both for software algorithm and hardware, the idea being really to check the behavior. And then we have the interface level, so in which we take 2 components and validate the communication between them, validate especially that it complies to the specification of the communication protocol, especially when it is a broad standard protocol, such as flex offer. And so yeah, this here really aims to check all of the basically all of the messages that can be exchanged between 2 components, and check that both components can understand each other. And finally, we have a 3rd level of testing, which is the integration test, in which we take all the components of a system together and check the behavior, the global behavior of the system. So this is really based on the use cases in order to validate the global behavior. And we follow the interaction between the systems from the occurrence of an event in the electric network until the activation of the flexibility from the assets. and validate really that each component sends the right messages to each other. Yeah, and so once all this is validated, we can validate that the global system is ready to be implemented in the pilot. So here we have a test specification. I just wanted to mention this because I wanted to show how we formalize this test. So here in this testing specification, we have, of course, the identification of the test, the description of its objectives, what equipment should be tested, and then we have a step-by-step analysis of what should be done by each of the components. And also, in the end, once the test is passed, whether it is a pass or fail, the person executing the test fills the second section on test execution in order to be able to follow what are the execution of a test and how the system behaves, and especially what should be improved in the system. Thank you.
Thank you, Dun. So to conclude on this topic, I invite all the participants to stay a few more minutes, like 5 minutes maximum, just to have a quick overview of the activities of the Data Management Working Group or the Bridge initiatives. Olivier, the floor is yours.
Yes, thank you. So I will try to summarize in a very few minutes what we've done in several years. So Bridge initiative is, in fact, an initiative launched by European Commission in 2016, so more than 5 years ago. And in fact, the initial idea was to involve all the research and innovation projects from the Horizon 2020 project program and now Horizon Europe, related to smart grid, energy storage, islands, so including GIFT and MAESHA, and also digitalization. So you have some figures here, probably they are even higher now, because we are reaching now €1 billion funding and more than 90 projects since the beginning, but currently we have a little bit more than 60 projects ongoing. And many organizations and many experts that go in several working groups. And I'm currently the chair of the data management working groups, in which we are looking at communication infrastructure, cybersecurity and data privacy, and a specific focus on data handling and data exchanges that includes interoperability. So if you go to the next slide, I will have a specific focus on one of the actions that we are running for 2 years now, related to the interoperability of flexibility assets. So the initial idea we had, you can see it on the left, was to look at how we are able to have interoperability for flexibility. And for that, we say that, okay, we have many projects that are looking at interoperability, but they have different ways of doing flexibility, but also on the way to activate it, to define flexibility use cases. And if we want to look at what they are doing, we need to have a common ground. We need to identify commonalities between projects. And for that, we need to define a reference framework. So you see on the left, the methodology that we define, in which the green part, which is the reference framework, is defined based on generic business processes, which are the processes that we are using for flexibility activation. And in fact, we use this reference framework as a common ground, so we can use the contribution from the project, the architecture they have, so we can extract some information and at the end, be able to compare what are the standards that are being used by each project and if there are any gaps that can be identified. So this cross-project analysis is what you can see on the right. So you may be familiar with the smart grid architecture model, which is defined with several layers. What is the architecture of a smart grid system? And then you can see that if we have this generic business process on the right, with all these boxes that define what is the processes and how it goes from one actor to the other one, we can see that if we look at the SGAM function layer, which define all the functions that we have in the system, and if we look at the SGAM information layer, which define how the information is shared, we are able to look at different architecture from different projects and each time map it to the same generic business processes, and finally we are able to compare and cross-analyze how different projects are implementing similar flexibility processes. So in 2021, we looked at 38 use cases from 14 projects. You can see a list here to achieve some generic results from related to flexibility standard and solution. So if you go to the next slide. So the main result that we had this year, and that will pave the ground for next year, is that currently we have defined five general business processes that can be reused as a basis for flexibility solution development. The first one is related to flexibility for grid operator via open market, meaning that there is a negotiation and several options are negotiated, or via prior bilateral agreement, meaning that the DSO or other grid operator will directly negotiate with flexibility provider. We also have the BRP portfolio optimization, which is quite specific, and we have added energy committee optimization and implicit demand response based on price signal, for example. We also have developed a catalog of standards that shows for each of the interface that we have in the general business processes, what kind of solution or standards are being used by the project. And also we have identified some gaps or some required extensions that we will push to standard developments. And in the coming year, we will work on that and improve the general business processes to better cover the flexibility use cases, but also in the future to include also other use cases beyond flexibility. Thank you.
Thank you, Olivier. So here we are at the end of this webinar. So I do not see any question in the question section, but please, if you have any question later, please do not hesitate to reach us. So I hope those presentation give you a nice overview of what is needed to implement the flexibility markets on islands. I would like to thank all the panelists and to congratulate them for presenting such a complex topic in a short period of time and in a way that was easy to understand. So thank you very much. And I would like also to thank all the partners who work behind the scenes, so the Euro Quality partners who organize these webinars. And finally, I would like to thank all the participants to this webinar for expressing an interest in flexibility. And of course, if you have any question, please feel free to reach us, to visit our website, or to follow us on our social accounts. All the slides and the recording will be shared. So I wish you all a nice day. Thank you.